In the previous episode, I showed you how to solve this linear problem. And we determined that a feasible region is the blue region that you can see in this picture with 3 corner points, A, B, and C. And you can determine the coordinates of those corner points. We actually did determine A and we determined C. You can also do calculation for B. B can be found as an intersection of constraints 2 and 3. And then we also determined, right, either using the level curves, that the optimal solution for this problem is point C, because the highest value we can achieve is 17. Right, the highest level curve that still crosses the feasible region is this line for value 17, and crosses point C, and there is no feasible points which lie on a higher line. Or you can use also the corner enumeration method, and you can find corner A, B, C, which are here, and then you determine their objective values, and then you will see by comparing them that this one is the largest. So this is the optimal solution. So this is what we did in the previous episode. What I would like to do now is modify this model slightly and see what happens. In particular, modify constraint number 3. Constraint number 3 is now a less than or equal constraint, right? So this is the less than or equal. What I want to do is I want to change it to equality, right? And I want to see what happens had this been equality. Right, so if this is equality, let's write this in red. Right, this is x1 minus 2x2 equals 0. So what changes in this picture? So first of all, what we need to see here is that before, when we were drawing the constraint, we saw that this line number 3 that goes here, right, this line, this is the line where constraint is satisfied with equality, and then we saw this side of the constraint which satisfies, these are the points that satisfy the constraint with less value of the left hand side, which was less than 0. Now we're not allowing less than 0, we're just saying instead of less than or equal to 0, we're saying exactly equal to 0. So now what we need to consider is we need to consider points that are only on the line of constraint 3, on this line of constraint 3. So what changes now? Notice these are all the points on this line, and then we will also consider that, of course, 1 still has to be satisfied, so they have to be above this line, and then 2 has to be satisfied, so the points have to be also below this line. So we are going to trim here this line. So what is the feasible region now? The feasible region is no longer this blue area. So we have to erase the blue area, right? The feasible region is only consists only of the points that are on the line of constraint 3, but also limited by constraints 1 and 2. And of course 5 and 4 would also be limiting, except that they are redundant now, they are satisfied anyway still. So the corner point A and corner point B are still feasible, they are on the line, and then we also have to add all those points on the segment, right? It's a little bit thick here, but what we mean is that we are just indicating all points on the segment between straight line segment between points A and B. So what is the feasible? Let's write this feasible region. Now, this feasible region is straight line segment A, B, right, between points A and points B. So actually C is no longer a corner point, right, because C is not on the line of constraint 3, right, therefore it's no longer a corner point. And now using the corner point method, we can determine the optimal solution by choosing either A or B. It could be that Both could be optimal in some cases, but in this case, B has a higher value. So in this case, this is max now, and this is optimal solution, right? Now, so B is the optimal solution. And of course, we could also do this using the level curves. We can see that if I do the level curve that is parallel to this, but there's no longer any feasible points on this line. I have to go back until I reach point B. This is where I will reach it. And then there is a level curve here that I can plot. And this level curve is for value 13.32, which we determined as the value of achieved at point B, and there are no more feasible points above, right? There's no more feasible points above where we would like to go when we maximize the objective, and all points below are worse. So B is now the optimal solution. Okay. Another modification I want to consider is what if there was another constraint that's equality. So let's say if I had constraint 1, if constraint 1 was also equality, so let's make this constraint 1 as well into equality. Right? Again, what will this change? Now, when we were plotting constraint number 1, which is here, right, this constraint, we said this is where it is satisfied with equality, and then we said on this side is where it is satisfied with inequality, right? But now only equality is allowed. It has to be equal to 3. So this no longer is allowed. We should now consider, right, the same way as this was not allowed before when we consider 3 to be equality, right? So now we need to consider that the feasible region will change again. The feasible region points have to be on this line, and they therefore cannot be those points here, right? They can't be these points, right? Only point A is going to be the feasible region because it satisfies with equality constraint number 1, right? This constraint, it satisfies with equality, and constraint 3 with equality, right? They are equalities here, right? So, and then all other constraints like constraint number 2 are still satisfied. This is of course wrong, right? This cannot be. So constraint number 2 is still satisfied, and 5 is still satisfied, and 4 is still satisfied because we are on the right side of the constraint. So we have only one feasible point. So in this case, again, right, the situation changes. Now even B is not feasible. So I can cross it out of corner points, and the only corner point, well, actually the only feasible solution, right, of this problem is point A. So feasible region now is not a straight line segment or anything like this. It is actually only point A. Only point A is feasible. And because there is only one point to choose from, that means the optimal solution now is point A, right? A is optimal solution. And again, our objective, the maximum value we can achieve is just 6. So we could plot a line here and show value 6 for it. Right? So this is what happens when you have equalities. If you have equalities, they narrow down the choices very much. If you have one equality, there will be a straight line segment or a line. All points feasible will be on this constraints line. And if you have two equalities, if they are not linearly, if they are not parallel, then you will have only one point that's feasible.